Good morning, student. Today I am going to cover a small portion of this topics flotation and buoyancy, which comes under the chapter fluid statics. So let us have a small recapitulation of the earlier class. What you have learned in the earlier class, that is how to determine the resultant pressure and the center of pressure for any vertical immersed surface as well as for any inclined surface. Am I clear? I think we got that formula also derived. What is that? If you can have a recall, that is resultant force is equal to W A x bar for both vertically immersed surface as well as for inclined surface. And regarding Cp, that is center of pressure, what is that? The formula says it is ICG, means moment of inertia about Cg divided by Ax bar plus x bar. This is for vertically immersed surface. With a small difference for inclined surface, the Cp is ICG sin square theta by Ax bar plus x bar. So what is that? Theta extra here. Theta is the angle of inclination for the inclined surface, making the angle with the horizontal, not with the vertical. Mind it here, not with the vertical. Okay, now let us come back to our present topics. So here I think most of you have already learned in your class 11-12 science, that is physics. Still, as now for engineering purpose, so we are again redoing the same with the motivation that why civil engineers should know all this knowledge regarding the flotation and buoyancy, because many a times you will be constructing some structure which will be floating in nature. So there resolving the forces and the point of action of the forces are very important to know, for which you have to be knowledgeable on these particular topics. Am I clear regarding the motivation part? Now let us come back to the subject. What is buoyancy here? If you try to recollect, what is buoyancy? Buoyancy is an upward force exerted by the liquid. What is that liquid? Suppose you are trying to put an object. You are trying to put an object in the liquid or any fluid. What is happening? So this particular object will be displacing certain amount of fluids. So I am repeating. So that object will be displacing certain amount of liquid. Am I clear? So that displaced amount of liquid must be possessing a certain weight. Am I right? So that weight will be acting against the natural weight of the body, which is called the buoyancy force. So if you take, so this is the normal W, that is the weight of the body. Now with this amount, which is that amount of liquid displaced by the body, so it must be having certain weight, and that weight is equal to the buoyant force, and that will be acting in the anti-direction of your normal weight. Clear? Now, what is the point of application of weight, total weight? We know the total weight normally acts through the CG of the body, which is not changeable in any condition. It remains same with respect to the body dimension. Okay, now regarding the position of B, this position is called the point of buoyant force. It means this is the point through which the whole buoyant force acts against the natural weight of the body. So that is how it is decided whether this object will be submerged or will be floating on the liquid. Okay, now regarding this point of application means the whole buoyant force, if you sum it up, that will be acting at B. Why? How it is decided? It is at B, because if think B is the CG point of the displaced liquid. I am repeating, B is the displaced CG of the displaced liquid. Means whatever liquids are displaced by the body, that also must be having one CG, and that is nothing but the B, and which is known as the point of buoyancy. Clear? Now let us see. So this particular axis is called the normal axis, on which suppose a body is floating in normal condition. It must be possessing a center of gravity. It must be possessing a center of buoyancy also. Now let us assume I am giving a tilt to the normal axis. What may go? So by giving a tilt to this axis, so the body naturally will take a turn and it will start oscillating on this normal axis. You assume or imagine the situation. You have given a tilt and you release that force. So what will happen? Now it will be just oscillating like a pendulum. Now what is happening at that point of time? Now see, that body having a G which is fixed in nature, G is not going to change. Now the B, whatever was there in the normal condition, that is the point of buoyancy, that gets shifted towards the tilting side. So what is happening? So B is now shifted to B1. So due to that, what is happening? Let us see. We can find out the point of oscillation. How? There is a technical method. So from this shifted position of the buoyancy, if you develop a axis, normal axis, which will be meeting the normal axis of the body at the point A, and this point A is nothing but known as the meta center. This is called meta center. Clear? So after giving the tilt, the meta center is created. Then what happens? Slowly, by the way of damping, it gets stabilized. Again, it's come back to its original position. Okay. Now, here from numerical point of view, we are supposed to know what is the position of M, where it lies. So to find out this GM, which is known as metacentric height. So we go by that. We will calculate what is BM, distance between B and M, minus BG. Okay, BM minus BG. Now how to find out this BM? So let us go for BM first. This BM is derived from an analytical analysis, from an analytical method of analysis for the wedge concept. So what it says? It says BM is equal to rho G I by W. This is what we get the formula from by analytic analysis from wedge concept. So what is this rho? Sorry, here I have made mistake. This is not W. This is rho G, because we know W is the specific weight is equal to rho G. That already we have learned. So here the rho G multiplied by I. What is I? You must be knowing I is nothing but the moment of inertia about that particular axis. Here my axis is that y axis, that is the vertical axis. And what is W? W is the total weight of the body. So if we know all these parameters, we can calculate the distance between B and M. Now let's over with this BG. What is BG? Now let us see. BG is this distance. So what is G? Let us take the help of a point A. So from this point A, AG. What is AG? AG is nothing but the height of the body or object divided by 2 if it is symmetrical in nature in the present case. So we can find out this AG minus we will find out AB also, that is AB. So let us say the height of immersion by 2. So ultimately what we have done to achieve BG? BG is nothing but AB minus AG. So this is representing AG and this is representing AB. So that is how we can find out this metacentric height. Could you understand all these things? How we will be calculating the metacentric height? So this is how we will be calculating the metacentric height. So remaining small portion is left out. We will cover up in the next class along with good example of numericals. Okay, thank you.